And again, this is the last chapter for the midterm period. So after this, you really need to prepare for the midterm na. Okay? So I hope na kakayanin. Okay. And also, mag-asynchronous na tayo starting Friday, no? So this will be our last synchronous session for the midterm then, no? So after this, we will just meet virtually. So I'll post recordings na lang. Okay? So yan. So, to kickstart chapter 4, here are the topics that we need to cover. In my class yesterday, we were able to reach up to this part. Okay? So, kasi madali lang talaga siya. And then the rest of the session will be done asynchronously. Okay? So, yung iba asynchronous. However, itong mga to, kaya natin to today. Okay? So, this is just a review on acids and bases. So, I know everyone's kind of familiar with that, with them. Okay? So, ayan. Hopefully, you will be able to understand it further in our session today. Okay? So, let's begin by characterizing acids and bases. No? So, we deal with acid and bases every day, no? So, especially, let's say, you're cooking, no? Pag nagluluto, let's say, ng paksiw, sarap, di ba? Pag may paksiw or adobo, sometimes you add acid in the form of vinegar or acetic acid. Kaya, when you eat fruits, no? Especially mga citrus fruits, they have acids, no? Citric acid. Kaya sometimes you eat bitter vegetables, no? And yung mga vegetables na yan, probably they have base compounds in there. Okay? So yun yung typical characteristic ng acid na. So we are exposed to them every day. Some of them are even edible, such as acetic acid and citric acid. Okay? So yun. So yun sila na. Okay, so yun yung mga acids natin. In general, acids have sour taste. Okay? Kahit anong acid yan, as long as it is an acid, maasim siya. Okay? And when you put it on top of your metal, let's say aluminum, okay? It will corrode the metal. Okay? So nasisira niya yung metal, and with it, it produces hydrogen gas. Okay? So kumbaga, there's a redox reaction that is happening in them. And also, acids react with carbonates and bicarbonates to produce carbon dioxide gas. Okay? So, siguro naman, everyone's familiar with the baking soda experiment, no? So, you add vinegar to your baking soda, then it will bubble. That bubble is actually carbon dioxide that is being produced by the reaction. Okay? So, yun yung typical characteristic ng acid. Maasim, it will produce hydrogen gas. Yan. And sometimes carbon dioxide gas. For bases naman, they are typically bitter in taste. Kaya nga minsan 'di ba may mga halaman na pag kikinagin mo parang ang pakla, tas madulas. So probably that's a base compound na. So they have bitter taste, mapakla sila, and they feel slippery, no? Such as those found in ampalaya, 'di ba? O, 'di ba pag tinikman mo 'yun, ang pait-pait, and then if you touch it, it's kind of slimy. Okay. So, yan. So, may mga base compounds doon. Some example of bases is yung soap. Okay. So, everyone's familiar with the soap. Mabait siya. Especially pag naliligo ka, tapos kunwari nadikit sa lips mo. Di ba minsan malalasahan mo, it's bitter. And of course, it's very slimy, no, or slippery. Okay. Pero, um, the goal of this chapter is for us to characterize what is an acid, what is a base, without even tasting them. Kasi itong slide na to, this is just about how we perceive acids and bases, no? How how do they appeal to our senses? Okay? Kaso, as scientists, no, we should be able to tell which of them is an acid or a base without even tasting them because again, everything's not edible. Hindi naman lahat tinitikman sa laboratory. Bawal 'yon. So, the goal of this chapter is for us to look into the molecular structure, look into the reactions so that we can classify which among them is the acid or the base. Okay? So, yan. Yan yung gagawin natin. And actually, you have an idea about it, no? Because last semester, we were able to discuss acid-base reaction. Okay? We defined acids as those that produces H plus and the bases as those who produces OH minus. Okay? But in reality, that definition is very outdated. Okay? So, ibig sabihin, our definition of acid and bases, nag-improve siya over time. Okay? So, in our session for this day, we'll talk about the different definitions of acids and bases according to chemistry. And some of them are the following: Arrhenius definition, the Bronsted-Lowry definition, and the Lewis definition. Okay? So, discuss natin sila. So, marami yan, no? Actually, around 10 yung definition ng acid bases natin. Okay? Meron pa nga tinatawag na hard-soft acid-base theory. Sila yung reason bakit may precipitates. No? Okay? Ano pa ba yung mga acid-base definitions? Basta marami siya. No? So, if you try to Google that, lalabas yung mga lalabas yung ating mga definition. No? Okay? So, as in, super dami niyan. No? If I am not mistaken, around 10. Okay? Wala yung table dito. Anyway, sa inorganic chemistry kasi yung discuss yun. Okay? Anyway, so, but for the simplicity of this course, we will just talk about Arrhenius, the Bronsted-Lowry, and the Lewis definition. Okay? Para madali lang. So, let's talk about Arrhenius. Okay? So, you are very familiar with this one. Okay? Because ito yung ginagamit natin last semester. When we define acids, acids are substances that produces hydronium ion or protons when it dissociates na. And bases are compounds that produces hydroxide and ion when it dissociates in aqueous solutions. Okay? Ganun lang siya ka-simple. Okay? So, acid, proton yung cation, and then hydroxide yung an ion for a base. Diba? So, very familiar tayo dyan. For example, we have HCl and sodium hydroxide. HCl is classified as an Arrhenius acid, and sodium hydroxide is classified as an Arrhenius base. Okay? So, yan. As you can see, the proton here in this molecule is H. Okay? So, siya yung cation natin. So, ang cation is yung H, ang anion ay Cl. So, meaning, this is an acid, no? Because if you dissociate this, H plus will exist. Okay? For the base, ang anion mo naman ay OH. So, ayan, obvious naman OH yung anion natin. So, that's an Arrhenius base. Okay? So, very simple lang, no? Pero, when it comes to other compounds, no, they cannot use the Arrhenius definition. Okay? For example, ang ammonia. Have anyone tried smelling ammonia? Nakaamoy na ba kayo neto? Sino yung nakaamoy na ng ammonia? Ito yung pinapaamoy kapag nahihilo. If you feel dizzy, you passed out, they will allow you to smell ammonium bicarbonate. Okay? Papaamoy yun sa ilong mo. Wala pa nakatry. Wala pa. How about sa mga public urinal? Alam niyo yung mapanghi doon? That's ammonia. When urea decomposes kasi, it produces ammonia. So whenever you pass by a public urinal and it's very stinky, that's ammonia. Okay? So, yun, ammonia. When you try to get the pH of ammonia, it's actually basic. Base siya, bale. Pero, with Arrhenius definition, it doesn't seem like it is a base. Why? Because look, no, wala siyang OH eh. The atoms are nitrogen and hydrogen alone. Walang OH. So, how come na yung ammonia, it's a base, pero wala siyang OH? No? So, kumbaga, there's something missing in the Arrhenius definition, right? May kulang sa kanya. So that's why a new pair of scientists worked out this problem, and they are called Bronsted and Lowry. So si Bronsted and Lowry, dalawa silang chemist, okay, that tried to expand further the definition of Arrhenius. Kasi kay Arrhenius, ang base ay OH donor. Magbibigay siya ng OH, di ba? Pero, in the context of ammonia, by just looking at the formula, parang wala namang OH. So how come that will be basic? Another example would be baking soda, sodium bicarbonate, that is a base. O, wala naman tayong OH doon, NaCO3 yun. So there's no hydrogen to form the OH, diba? So those are the questions that Bronsted and Lowry were thinking of, no? Like how come they are acids, or how come they are bases? So they redefined the acids and bases into something that is much simpler. So according to Bronsted and Lowry, sabi nila that yung acids, they are proton donors, while bases are proton acceptor. So tinanggal na nila yung requirement na OH, okay? Because again, remember, for your Arrhenius definition, you need to look for an OH, okay? But in the definition of Bronsted Lowry, they made it more broad, na parang mas naging simple yung definition. Kung sino yung naglabas ng H, or whoever the proton donor is, that is an acid. Kung sino yung tumanggap ng H, siya si base. And with this redefinition of acids and bases, ang daming nangyari sa chemistry. Okay? Since we are just looking now at the hydronium ion, titignan mo na lang yung H atom. So, mas madali na mag-identify ng acids and bases. Okay? So, meaning yung ating ammonia and yung mga sodium bicarbonate, let's say, you can now define them as either an acid or a base. Okay? With the help of Bronsted-Lowry definition. All you have to do lang is to look which of them gave off proton, which of them take in that proton. Okay? Kung siya yung naglabas ng proton, it's an acid. Kapag siya yung tumanggap ng proton, that is a base. Okay? So let's look at some examples of Bronsted-Lowry definition. Okay? So let's have here HCl in water solution. It produces H3O plus and Cl minus. Okay? So tingnan niyo, no? So let's try to pair up the original molecules with their product counterparts. Let's try to pair them up. So let's say HCl, ito yung kapartner niya, the Cl. Then H2O, ang kapartner niya ay H3O, right? So sila kasi similar to one another. Now, our task is to identify which of them released a proton. Okay, dito sa reactant. Which of them do you think released a proton? Sino kaya yung nagtanggal ng proton, nawalan ng H? Is it the HCl or is it the water? Sino yung nawalan ng H? So look at the purple line because it shows you the final product. So sino kaya sa dalawang to yung natanggalan ng H? What do you think? Ano? Sino yung nawalan ng H? Si HCl ba? Or si H2O? Any idea? Si HCl, correct, na? So look, na, before, si HCl, may H siya, is isang H. However, upon the reaction with water, it just turned into Cl minus. Diba? So, ibig sabihin, it lost a proton. And whenever you lose a proton, ano nangyayari? You actually become a Bronsted-Lowry acid. Okay? Bl acid na lang shortcut natin. So that is a Bronsted-Lowry acid. Kapag siya ay nawalan ng proton, okay? Or H plus donated. So meaning HCl is not only Arrhenius acid, it can also be classified as Bronsted-Lowry acid. Okay? So Bronsted-Lowry acid din pala siya. Now, let's look at water. Okay? So si water, what happened to it? No? Nangyari sa kanya, originally it has 2 hydrogens, but on the product side, what happened? It now turned into H3O+. Kumbaga, nadagdagan siya ng proton ng H+, right? So meaning, since it accepted the proton that was donated by the HCl, meaning, siya ay isang Bronsted-Lowry base. Okay? So again, Bronsted-Lowry base, those are the molecules that accept proton. Okay? So si acid siya yung nagdodonate ng H+, si base siya yung tumatanggap ng H+. Okay? So all we need to do is to just monitor where the hydrogens are na. Ayan. Okay, so ito medyo na-typo ako. Sorry for that. Yan. So let's try to look at this reaction below. So let's pair their counterparts. Of course, si NH3, ito yung kapartner niya. Kasi para sila may nitrogen. This one, ang partner niya is the Cl-. Now, between the two reactants, which is a Bronsted-Lowry acid, which is a Bronsted-Lowry base. Sino yung Bl acid? Sino yung Bl base? Okay. So just look at the number of protons they have after the reaction. Okay, could you send it to me? Send nyo nga sa chat box. Sino kaya yung Bl acid? Sino yung Bl base? Okay, sige. I'll keep the answers coming lang. And then let's check if that's correct. Okay, and so good. So in the reaction shown, HCl is still a Bronsted-Lowry acid, no? Okay, it's still a Bronsted-Lowry acid because it will give off the proton. Okay, so from HCl it will turn to just Cl-. So kumbaga natanggalan siya ng H+. And ammonia, no? So ammonia, tignan nyo. So it originally has 3 hydrogens, right? But after the reaction, it now turned into NH4+. So nadagdagan siya ng hydrogen. So that means it is a Bronsted-Lowry base. And ito yung pinaka reason bakit ang ammonia ay basic, okay? Ammonia is basic because it can accept the proton. So dati, in Arrhenius definition, they cannot tell bakit siya naging acid or base. Hindi nila masabi, why is this an acid? Why is this a base? Hindi nila masabi. Kasi ang definition ni Arrhenius, kailangan may OH. So, Bronsted-Lowry redefined that. So, sabi nila, so instead of looking for OH, you just need to monitor the proton. Pag nag-donate ng proton, Bl acid. Pag nag-accept ng proton, Bl base. And apparently, based on this reaction, you can see that ammonia did actually accepted the proton. So, tumanggap talaga siya ng proton. Meaning, it's a base. Okay? So, yan. Nasagot nila yung question nila dati. Okay? Na the reason why ammonia is basic, okay, bakit siya basic? Kasi it can accept a proton pala, reaction-wise. Okay? So, ganun din si carbonate, no? So, carbonate can accept protons. So, ganun pala, no? And actually, their definition is very revolutionary, no? napakalaki ng effect niyan sa chemistry. Because by just simplifying the requirements for acid and bases, we were then able to identify many acids and many bases. No? Ang dami pa palang acids and bases in nature. So thanks to Bronsted Lowry. Because without them, hindi natin alam yung acids and bases siguro. No? Siguro we're stuck with Arrhenius definition. Okay? And so thank you sa kanila. And now, let's reinforce our understanding of Bronsted-Lowry definition. So let's look at this molecule na. Okay. This reaction pala. When your ammonia is placed in water, it turns into ammonium ion and hydroxide anion. Alright? So as you can see, originally, your ammonia has 3 hydrogens. And after the reaction, it now has 4 hydrogens. Okay? Ibig sabihin, it accepted the proton, meaning it's a Bronsted-Lowry base. I'll rewrite everything dito ha. Kapag acid, it donates proton. Pag yan ay base, it accepts proton. Okay? And so Bronsted-Lowry acid, it donates proton. Pag base, it accepts proton. As you can see, ammonia is indeed a base. Because even with water, pagdating pala sa product side niya, it turns into ammonium ion. Kinukuha niya yung hydrogen ni water. So it is indeed a base. And water now is a Bronsted-Lowry acid. Okay? Kasi dalawa yung H niya eh. Then after the reaction, isa na lang. So it donated its proton. Okay? Now, the good thing with Bronsted-Lowry definition is that we have terms for them. Okay? Typically pala, Bronsted-Lowry definition applies for equilibrium system. Basta may equilibrium arrow, pwede siya magamit. Okay? So, may tawag pala sa products niya. What are they? They are called conjugate acids and bases. Conjugate means if the reaction is reversed. Okay? Kapag baliktad yung reaction. Okay? So, meaning, kapag baliktad yung reaction, they can also act as an acid and a base. Okay? So, itong ginawa kasi natin, this is just the forward reaction, right? So, if you want to form this product, ito kukunin niya yung proton. Okay? So, yun. So, meaning, ito yung Bronsted-Lowry base, ito yung Bronsted-Lowry acid. But what about its conjugate? When you say conjugate, yung kabaliktaran, the opposite way. What if we do the opposite reaction? Which of them will now give the proton? Okay? In the conjugate manner, kabaliktaran. Okay? So if we try to do the reverse reaction, so ammonia will seem to give off the proton. Okay? If again, pagbaliktad yung reaction, yung point of view natin ha. Kung gusto natin ma-form ito, ammonium ion needs to remove this proton. Okay? So, kumbaga, babaklasan niya yung proton na yan, so it will turn into this product in a reverse reaction. So, in a sense, if the reaction is reversed, ammonium ion will now serve as your acid, and your hydroxide, it will accept this proton, so it will be considered as a base. Okay? So, yan. If the reaction is reversed, the roles are also reversed. Yung dating base, acid na siya. Yung dating acid, base na siya. However, just to signify that the reaction is reversed, we need to add the term conjugate. Okay? So meaning this is called the conjugate acid. This is called the conjugate base. Okay? So again, what's with conjugate? Pag sinabi natin conjugate, if the reaction is reversed. And what will happen if the reaction is reversed, the roles will also reverse. If before siya ay base, now when you reverse the reaction, it's called a conjugate acid. Okay? Kasi if you try the reverse reaction, siya naman yung magbibigay ng H to form this, no? To form the reverse products. Okay? So meaning, ang ammonia and ammonium ion, we can call them the base conjugate acid pair, and the water and the hydroxide anion, we can call them the acid conjugate base pair. Okay? So ganun. Conjugate meaning if the reaction is reversed. And what's the matter with conjugate acid and base pair? Mapapansin nyo that if you have a base, its conjugate acid will have one more hydrogen. So tatlo yung hydrogen ng base, now it's 4. Okay? Ito shortcut ko. You can call it conjugate acid if yan ay nadagdagan ng proton. Pag nadagdagan siya ng hydrogen, kapag yan ay nabawasan ng H, so yan ay conjugate base. Okay? O, tignan nyo. So, H2O, nabawasan siya ng H, so that's a conjugate base. Look, na ammonia, NH3, naging NH4, so plus 1H. So, ibig sabihin, it's a conjugate acid. Okay? So, just para lang hindi kayo malito, the term conjugate means reverse reaction. Okay? So, this will serve as an acid, this will serve as a base if the reaction is reversed. Okay? Okay, so let's practice pa in identifying the conjugate acid-base pair. We have here acetic acid and methylamine, and the reaction proceeds as this. Okay, so the acetic acid will lose the hydrogen, and the lone pair of the nitrogen will be used to accept the proton. Okay, so what is the Bronsted-Lowry acid? And what type of conjugates are these products? No? Anong uri ng conjugate sila? Are they conjugate acid, conjugate base? Try to identify them. Anong Bronsted-Lowry ito? Is it acid? Is it a base? Is this acid? Is this a base? Acid ba to o base? Acid ba to o base? Try it na sa chat box. Ano kaya yung mga tamang names nila? Okay, sino kaya yung Bronsted-Lowry acid? By the way, yung Bronsted-Lowry, tawag natin yung sa reactant. But the conjugates sa products lang siya. Okay? Try to identify the 4 molecules. If they are Bl acid, Bl base, conjugate acid, conjugate base. Okay, so let's check your answers. Okay, so acetic acid, boron-lauric acid, methylamine, base, acetate ion, conjugate base, methylammonium ion, conjugate acid. That's correct na. Okay, so acetic acid is an acid, obvious naman because of its name. Okay, so it is an acid na because after the reaction, it turned into an acetate ion. Okay, nabawasan siya ng proton. So if acetic acid is an acid, that means acetate ion is the conjugate base. Okay? Always remember, kapag conjugate acid, plus 1H. Pero kapag yan ay conjugate base, yan ay minus 1 ng proton. So, ito may proton dito, ito nawalan. So, this is the boron-lauric acid. The product version is the conjugate base. Correct. So, for methylamine, it is the base. It's the boron-lauric base. Okay? And the product is called the conjugate acid kasi nadagdagan siya ng proton. So originally, we don't have any protons here, but now you have one. Okay? So ganun ang kaganapan. Okay? So the boron-lauric acid will always produce the conjugate base. Tandaan niyo yan. The boron-lauric acid will always produce the conjugate base. And the boron-lauric base will always produce the conjugate acid. Okay? Let's try another one. Let's try another one. So this is the reaction of acetic acid and water. Lalagay ko na lang yung name ha. Acetic acid. This is acetate. Sige. I'll try to identify the boron-lauric acid base, conjugate acid base. Okay, so ano kaya ang sagot? What is the boron-lauric acid, boron-lauric base, conjugate acid, conjugate base? Ano sagot natin? Okay, so yan ang answers. Okay. Acetic acid, H2O base, acetate base. Okay. So yun, correct again. So the correct order is this one is the boron-lauric acid. Okay. This is the boron-lauric acid. This is the boron-lauric base. And then acetate is the conjugate acid. Conjugate base pala. And this one is the conjugate acid. Okay. So again, the term conjugate refers to the product. No? Okay, because if the reaction is reversed, the roles will also flip. No? So kung dati siya yung acid, in the reverse reaction, it will be the conjugate base. Okay? So, ayan. So, that's the correct order. Tama naman yung answers niyo. This one is, yun na rin naman yun nandito sa previous slides. Okay? Wala ba kayo napapansin as we answer which of them is the acid or base? Okay? I want to see kung may napapansin kayo. There is a molecule here that seems to be an acid in some cases and base in other cases. May napapansin kayo kanina? May molecule na hindi mo alam kung acid siya o base kasi palit-palit siya. Okay? Anong molecule kaya yan? Slowly ko lang i-move yung slides, ha? So, sige. Tignan nyo, merong molecule dyan na minsan acid, minsan base. Okay? So, tignan nyo maigi yung ating slides. Okay? Okay? Yung water yon. Okay? So, look at water. There are cases na siya yung base. It is a Bronsted-Lowry base. And there are cases that it is an acid. So, what is water? Diba? So, actually, di ba, acid si water dito. Pagdating dito sa reaction na to, it is now a base. So, what happened? No? Especially dito pa lang sa slide na to. So, base tong water natin. So, what happened? No? Ano nangyari? So, ganito kasi. No? Ang ating water, it tends to be both acidic and basic. Okay? So, it tends to be both acidic and basic. Okay? Kaya siya tinawag nating amphoteric molecule. Okay? Amphoteric meaning it can act both as an acid and a base. So 50-50 siya. And the tendency of water to be both acid and base at the same time causes it to be neutral. Okay? Kaya yung tubig natin, neutral siya in terms of the pH. Or around 7 siya, neutral pH. Okay? So, ganun yung water natin. Medyo balimbing siya. Minsan acid, minsan base. Tawag doon, amphoteric. Okay? Or, pwede siyang acid, pwede base. Okay? So, water is among those molecules that can do that. Okay? So, isa siya sa mga iilang amphoteric molecules. Okay? So, ayan. So, yun lang na. So, Bronsted-Lowry definition, you have your Bronsted-Lowry acid, which donates proton, Bronsted-Lowry base, which accepts the proton, and their counterparts are called conjugate base and acids, respectively. Okay? And water, in this sense of Bronsted-Lowry definition, it may serve as an acid or a base at certain conditions. So, meaning, it is amphoteric. It is really neutral. Na? Kasi 50-50 yung chances niya. Okay? Now let's take a look at the last definition, which is the Lewis definition. So according to Lewis, Gilbert Lewis, siya yung gumawa ng Lewis structure. Okay. So according to Lewis definition, an acid daw is defined as a substance that can accept a pair of electrons, while a base is a substance that can donate a pair of electrons. We will not use Lewis definition that much naman. Okay? So, in analytical chemistry, ang pinaka ginagamit natin na definition is the Bronsted-Lowry. Okay? But I have to discuss this na because Lewis definition explains why I mentioned last semester that organic chemistry is just acid-base reaction. To my students last year, siguro naalala nyo pa or hindi na. Sabi ko sa kanila, when we discussed organic reactions, I told them that it is just an acid-base reaction. Okay? Because of the Lewis definition. Because look at what happens when we donate or accept the lone pair. So this is your Lewis acid, this is your Lewis base. What will happen if the Lewis base donates the lone pair? You form a chemical bond. Okay? So, ibig sabihin, organic reactions are Lewis acid-base reactions. Because, you form chemical bonds, you break them, diba? May nabubuo, may natatanggal. So, it's just an acid-base reaction. Okay? And marami pa yan. So, we are not only using Arrhenius, Bronsted-Lowry, and Lewis. There are lots of other definitions pa. Okay? So, yan. So, again, just to summarize everything, pag Arrhenius, okay, so I'll create here a table. Okay, so for simpler reference. Kapag Arrhenius, ang acid H plus donor, and then ang base OH donor. Okay, so para silang donor, H plus kay acid, kay base OH. Kapag Bronsted-Lowry, you have your acid as a proton donor and your base as the proton acceptor. Kapag kay Lewis naman, baliktad naman, the base is the lone pair donor and the acid is the lone pair acceptor. Okay? So ito lone pair yan na, yung pair of electrons, that's lone pair. Okay? So yun yung mga lone pairs na yan. So they use that to form a chemical bond. Okay? So ganun pala, no? So those are just 3 of the 10 definitions of acids and bases. When you took BS Chem, alamin nyo lahat yan. But for the simplicity of the course, we'll just study 3 of them. Okay? So, yan. So, yan yung ating table of summary. Okay? So, ito yung ilagay niya sa notes niya. Again, saan may na-form na chemical bond? Sa Lewis definition. Because when lone pairs are donated, the orbitals overlap, forming a chemical bond. Okay. Another example will be this one: boron trifluoride and ammonia. So you can see, wala namang H plus donor, wala namang OH na lumabas, right? But look at what happened. No? They still combined because of the lone pair of the nitrogen was donated to the boron atom. Okay, and that causes it to form a chemical bond. Okay? So, yun lang yung definitions ng acids and bases. Now, let's go back to water. Because earlier, in the Bronsted-Lowry definition, we realized that water is both an acid and a base. Why? Bakit? Because when you dissociate your water, okay, when it self-ionizes, which is called autoprotolysis, okay, kapag siya mismo nag-ionize, it produces both H plus and OH, an ion. So meaning that water is indeed neutral and it can act both as an acid and a base. Okay? Kasi dalawa yung ions niya, H plus and OH. Na? So water is neutral. Okay? And when we try to get the equilibrium constant of water, equilibrium ulit, let's try to write the equilibrium constant of water. It will be written in this manner. Okay? So always remember, in equilibrium systems, we should not write the liquid. Okay? We just write the aqueous species or the gaseous species. But in this time, we just write the aqueous. So Kc is equal to hydronium ion concentration times the hydroxide ion concentration. Okay? And yung H2O liquid, we don't write it because it is considered constant. This K, itong K na to, that describes the autoprotolysis of water, it is actually called the ion product constant of water, or Kw. Okay? K water. So this is one of the important constants in chemistry. the ion product constant of water. At 25 degrees Celsius, the value of the equilibrium constant for the water is 1 times 10 raised to negative 14. And yung 14 na yan, that is the reason why we have a pH scale of up to 14. Later on, we'll see. We'll see that. Okay, so yan. Itong 14 na yan yung dahilan. Bakit ang pH paper ninyo up to 14 yung kanyang values? Okay, later I will discuss that further. Okay, so what will happen if your H plus concentration and your OH are equal? So if they are equal, then the solution is neutral. However, if you have more acids, okay, if you have more hydronium ion than the hydroxide, that means your solution is acidic. While if you have more hydroxide than the H plus, that means your solution is basic. Okay, so yan. Okay, so in the lecture, this is lecture class ko, I mentioned that the K value changes per temperature. And that's the reason why food turns, yung food natin, it spoils faster in hotter temperature than in colder ones, no? So yung K value din ng water, it changes over time. So for example, in this graph here, in this table here, you can see that temperature dependence of the ion product of water, or the KW. Kung mapapansin nyo, iba-iba siya kada temperature. Kasi sabi ko nga, the K is dependent on the temperature. Okay, so let's try to use the problem, let's try to use this equation, the ion product of water, to answer this problem. Okay, so sabi dito, what is the concentration of OH ions in a HCl solution whose hydrogen ion concentration is 1.3 molar? Okay, so ang given, you have a concentration of acid which is 1.3 molar. Ang tinatanong is the OH minus. So how will you even solve for that? So if ganito, you are given the H plus and you are looking for the OH, you can use the ion product constant of water. Okay, so KW agad. So KW is the product of H plus and the OH. Since we are looking for the OH, okay, so you have to cross multiply the H plus, so that becomes KW over H plus. And then your OH minus can be calculated as in KW, that's 1 times 10 raised to negative 14 divided by the concentration of your H plus, which is 1.3. So what's the concentration of OH then? Ano yung concentration ng OH? Okay, so the base concentration is 7.7 times 10 raised to negative 15. Okay, 7.7 times 10 raised to negative 15 molar. So what can we say about the concentration of OH and the H plus? We can say that the concentration of H plus is greater than the concentration of OH. Now, the question is this acidic or basic or neutral? Is the solution acidic, basic, or neutral? What's your answer? Ano kaya ang kasagutan? Is it acidic, basic, or neutral? So siya ay, tingin tayo sa slide kanina. So if you have more H plus than the OH, that is acidic. Okay? And always remember that. Na? If you have an excess of H plus, meaning that is acidic. Okay? The solution is acidic. However, if yan ay baliktad naman, you have more OH than the H plus, so that is basic. And if they are equal, that is neutral. Okay? So now, we talked about pH in the lecture. Okay? Whoever your lecture instructor is, na-discuss dun yung pH, right? And the p-value is just the negative log of the concentration. Okay? For this lesson, we're going to use pH and POH. Pwede rin POH. Okay? So again, the equation for p-value is it's a negative logarithm of the concentration. So if you're going to get the pH, you get the negative log of the concentration of H plus. Okay? And now, what will happen if you have a neutral solution? Okay? If you have a neutral solution, the concentration of H plus is 1 times 10 raised to negative 7. How were we able to get that? Okay, so we begin with the Kw first. No? So remember is the H plus OH minus. If they are equal, we can represent them both as X. No? Kung sila ay equal. And this is 1 times 10 raised to negative 14. So that will be X squared. 1 times 10 raised to negative 14. I'll get the square root of both sides. Then that means the concentration of H plus is indeed 1 times 10 raised to negative 7. Okay? So anyway, so if you have a neutral solution, the concentration of H plus is 1 times 10 raised to negative 7, the same as the OH. If you try to get the negative logarithm of that, you will get pH equal to 7. Okay? That's why ang pH 7 is the neutral pH. Okay? So, dun yung galing. Okay? So, the pH is 7. What will happen if you have an acidic solution? If you have an acidic solution, that means the concentration of your H plus will increase. Okay? In terms of pH, it decreases. Okay? So, kumbaga, the trend is reverse. If the concentration of H plus increases, the pH tend to decrease. Sorry, may question pala. Sir, lagi po bang 1 times 10 raised to negative 14? Yun parati gamit. But negative, ha? Yan yung mga constant na na kakabisaduhin natin. Okay? Anyway. As you can see, if the concentration of your H plus increases, the pH value tend to be less than 7. Why is that? Bakit kaya opposite yung trend nila? Well, it has something to do with the negative sign. Okay? Okay, so the negative sign in the logarithm tells you that there is an inverse relationship with the concentrations. Okay? Ibig sabihin, kapag mataas ang pH, mababa yung OH. Mababa yung H plus. Kapag mababa yung pH, mataas yung H plus. Okay? So that's why if you have acidic solution, the pH is less than 7. And if you have a basic solution, you have a pH greater than 7. Okay? So always remember that the trend is opposite. Yung trend ng concentration, the p-value is opposite. Just because of the negative sign in front of the logarithm. Tandaan nyo yan always. On this table here, we have the pH values of some fluids we have at home. Gagawin nyo parang ganito. You look for fluids that have specific pH value pero rounded off to to integer value. For example, you get a lemon juice, so the pH is 2 daw. Vinegar, pH is 3. So, pwede nyo to gamitin sa experiment na. Okay. And then, kunwari, urine. Kung matapang kayo, sige. pH 5, sabihin natin. Saliva, kung kaya nyo, pwede rin naman. If you remove the gross factor, okay lang naman. So, that's pH 6 or 7. Kunwari, gusto nyo ng tears dahil sa exams natin. Pwede nyo yung gawing representative sa pH 7 or pH 8. It's up to you. So, bali ganyan yung inyong home lab activity. No? So, you'll look for a representative for every pH. No? Ganun. If you want to collect tears, edi sige. Wag naman blood. Medtech lang pwede gumawa niyan. Okay? So, ganun ha. Okay. So, just always remember that the trend for the concentration and the p-value are inverse, meaning when the concentration of acid increases, the pH value decreases. Because I encountered some people that are understanding this incorrectly, no? Baliktad yung understanding nila. Okay. Basta correct na lang natin that because of this negative sign, the trends will be opposite na, in opposite directions. Okay. Here are some other important relationships. Okay. So remember that other than the pH, we can also have POH. And we can just simply replace the H plus with the OH concentration. Now, if we apply the negative logarithm to our equilibrium constant, what will happen? Okay. So let me show you what will happen. So Kw is the product of H plus and OH, right? If you try to apply the negative logarithm on both sides of the equation, you will get negative log of Kw equals the negative log of the product of H plus and OH minus. Now, what's the negative logarithm of Kw? So Kw is 1 times 10 raised to negative 14, right? So if you try to apply the negative log, it will be 14, okay? Just to prove you, so this is 1 times 10 raised to negative 14. If you try to get its negative log, it will just be 14. This is the reason why the pH scale is up to 14. Okay? So yung KW yung may dahilan. Siya yung may kasalanan. Bakit siya up to 14? Okay? Yan. So you get this. Now, what will happen with this logarithm? As you can see, the logarithm of a product, if you recall your algebra correctly, so according to algebra, the logarithm of a product, or let's say x and y, it can be rewritten as the logarithm of x plus the logarithm of y. So basically, we can split them. So we can split the logarithm, so we'll get negative log of h plus the negative log of your OH. You know that the negative log of H plus is the pH, and the negative log of OH is the POH. So that means pH plus POH equals 14. Okay? So pag pinag-add mo yung pH at POH, it will always be equal to 14. Okay? Siguro you might ask, are there instances wherein the pH is negative or greater than 14? Nagsi-zero din po ba yung pH? Yes. Okay. To be honest with you, that happens. Kailan? Nangyayari yon if you have a very concentrated acid or a base. So yan. If you have a very concentrated acid, let's say 35% hydrochloric acid or 85% sulfuric acid, yan. Ang pH nun less than 1. Minsan negative pa nga. So if you have negative pH, then those are very corrosive. Masisira talaga yung skin mo. They will burn. No? So ganun. Anong substance po ang pinaka-acidic na? Actually, napanood ko yan last time sa SciShow. Okay. Ano yun eh? Ako may fluorine. Okay. Nakalimutan ko lang yung name. Antimony something. Ayun, antimony something. Antimony na may fluorine. Yun lang naaalala ko. Okay, it's fluoroantimonic acid, no? So, yan, fluoroantimonic acid, which is a combination of antimony and hydrofluoric acid, no? It is octahedral, and it is very acidic, no? So, let's read the Google. Sabi niya. Extreme care must be taken, exceptionally corrosive, pero pwede siya sa Teflon container. Okay? Oh, look at the pH value. My God. It's negative 23. Grabe. Ayan, so it's negative 23. Pero chemicals like this, I don't know if they have practical use. Okay? Pero if wala kasing practical use, it's nothing eh. Parang wala lang din. Okay, just to prove the existence siguro, okay. Pero kapag wala naman siyang purpose, then hindi naman siya ganun ka-important bilhin. So ayan, it's among the super acids, no? Super acids are acids with very high purity, meaning they have very low pH. No? And sometimes they become negative pa nga. Okay? So yan. Sa base naman, most basic substance, alam ko meron din. Pero wala namang pumapansin dyan. Ito, watch this one from SciShow na lang. I always watch this when eating lunch eh. Lang. Kahit napanood ko na siya, I will watch it again. Parang hindi na tayo nasanay kumain na walang YouTube na. And, so yan. Sa bahay natin, we have acids na that have pH value of 1, such as those found in our stomach. No? And as you can see, no, 1, ibig sabihin, it is the same as muriatic acid. Yes. So our stomach acid is very strong. And that's why I can feel it right now. Acidic kasi ako eh. Nafe-feel ko na yung acid sa akin sikmura. Okay. The only reason why our body can handle this acid is, we have so many linings in our stomach. Na? Bio kayo, so mas alam nyo to kaysa sa akin. So our stomach lining is, regenerating fast, di ba? Mabilis siya mag-shed and mag-replace ng cell. So that's why our body can handle it. Okay. Okay, so masyado siyang matapang. Okay. And sa base naman, ang siguro pwede nyo gawing example is the sodium hydroxide. Remember last semester you made soap? If you still have sodium hydroxide from last semester, then yan, pwede nyo siya gamitin for the experiment. But just be careful, okay? So yun. Ano pang isa pang form ng sodium hydroxide? Pwede rin yung liquid sosa na, or the drain cleaner. It's composed of sodium hydroxide also. But be careful lang when dealing with those chemicals. Yan. Okay, so yan lang. So that's the acid-base property of water. Remember that it is an equilibrium system between the ions of your water and the liquid water. If you try to get its equilibrium constant, it is equal to 1 times 10 raised to negative 14. And that equilibrium constant changes at different temperature. So that also suggests that the pH of the solution changes at different temperatures. Okay. And then we can manipulate the ion product of water to get the relationship pH plus pOH equals 14. Okay. And do not forget the inverse trend of the pH and the concentration of H+. If you have a very low pH, that means you are acidic. If you have a very high pH, that means that is basic. Okay? Wag na pagbaliktarin kasi may ganun pa rin ako dating student. Sayang yung score. So, ano na, ayusin. Okay? So, there you go. Let's try to answer some of these problems. Okay? So, I'll only answer one and then kayo na bahala sa isa. Na? So, I'll wait for your answer dito sa second one. But let me just demonstrate you how to answer item number 1. So, the pH of rainwater collected in a certain region of the northeastern United States on a particular day was 4.82. Siguro acid rain yan, no? What is the H plus ion concentration of rainwater? Okay? Ano mangyayari kung buhos po sa balat? Yung acid, kapag acid yan, masusunog yung balat mo agad. Like, mangingitim and then it will be very painful. And kapag yan naman ay base, your skin will literally turn into soap. Magiging mushy yung iyong skin. Like, 'di ba kung nanonood kayo ng horror, ganun na ganun yung nangyayari. So kapag may sodium hydroxide, it will eat your flesh to the point that it becomes soap. Why? Because our body, our skin is composed of fatty acids. May mga fatty acids dyan, may mga taba-taba. So those fatty acids can react with the soap to form, can react with the base to form soap molecules. So magiging soap yung iyong balat. Pero not the good soap, no? The dreadful one. If you watch too much horror, mga gore, which I like, yan mga favorite ko. Legit yung ganong mga pinapakita nila. Okay? So kapag acid, you know naman, no? Kapag kayo ay, let's say, may hyperacidity like me, mafe-feel nyo yung, alam nyo yung GERD, gastroesophageal reflux disease ba yan? Parang nasusunog yung esophagus mo. And that is actually dangerous because it can lead to cancer. Okay? Esophageal cancer. Yeah. Okay, so anyway, let's go back. So, in this problem here, you are given the pH of the solution, pero you are asked what is the H plus concentration. In the lecture, chapter 2, na-discuss yan, that if you are given the px value, you can actually solve for the concentration of x using the antilogarithm, right? So, to get the x, all you have to do is to do the antilog, wherein gagawin mo lang exponent ng 10 si px. Okay? So, to get the concentration, that will just be 10 raised to negative px. Okay? So, yan. So, now, let's try to get the H plus ion concentration. So, all we have to do is to raise this pH by negative, make this pH the exponent of 10. Okay? So, that will be 10 raised to negative 4.82. Or the concentration of H plus is okay, so it will be 10 raised to negative 4.82. And so this is the H plus concentration. Okay, 1.51 times 10 raised to negative 5. Molar, of course. Heartburn, yes. Okay, so ganun lang kasimple. I'll try to answer the next one. There are two ways in answering this. Okay? Pero sige. Ano sa tingin nyo yung pwedeng sagot dyan? Given the OH concentration, find the pH. So siguro I'll give you, let's say, 2 minutes, 3 minutes to answer this. Wait ko na lang yung answer nyo in the chat box. Okay. So again, there are two ways in answering this one. Pero bibigyan nyo lang yung final answer. Okay? So comment nyo na lang sa chat box yung answer nyo. What's the answer kaya? According to a tweet, since today is the first day of alert level 1, okay, so we have more fluid movement na. Okay, so ibig sabihin, there's minimal observance of social distancing na. Marami na ulit tao sa labas. Last time I was in Star City, grabe ang haba ng pila. So, kung kayo gusto nyo pumunta with friends or family, wag muna. Promise, mauubos oras nyo. Yung 400 pesos, ilang rides lang siya. Hindi sulit. Okay. Palipasan yung mga 1 month. Okay. The pH is 6.60. Let's check. So there are two ways in answering this problem. Okay. There are two ways. So first one, you get the OH concentration. Then you convert it into POH and then to pH. Sino yung gumawa nito? Yung from OH, ginawang POH to pH. So sino yung gumawa niyan? Wala. Baka mamaya wala kayong answer. Okay lang, kumakain kayo siguro. Okay. Pero I hope na nasusundan niyo yung ginagawa natin. Okay. So, ito yung first way. From the OH concentration, you convert it into POH, then get the pH. Another one is to get the the OH concentration, convert it into H plus concentration using Kw, and then turn it into pH. Okay? So, yan yung mga pwede gawin, right? Itong second sa Louie. Okay. So, yan. So, those are the things that we can do. Na? So, pwede from OH to POH, then pH, and pwede naman from OH to H plus, then pH. Okay. So, the reason why I'm showing you this is that for you to have more options, no? Whether you choose one method or the other, they will eventually end up with the same answer naman. Okay? So, I'll try the first one. So, from OH to POH. So, I'll do that. Asan yung aking mouse? Ayan. So, the POH is just the negative logarithm of the OH concentration. It's negative log of 2.5 times 10 raised to negative 7. So, the POH is negative log 0.5 times 10 raised to negative 7. So the POH is 6.60, right? But to get the pH, remember, pH plus POH equals 14, right? So if you want to solve for the pH, then you have to transpose the POH on the other side. So that will become 14 minus POH. And that will be 14 minus POH, or 14 minus 6.6. The answer is 7.4. Okay? Correct yung 7.4. What's the other way? The other way is to use the equilibrium constant. Okay? Remember, Kw is equal to the product of concentration of H2O and the OH. We want to solve for the H plus, right? So, kunin mo yung H plus, that will be Kw over OH concentration. Kw is 1 times 10 raised to negative 14. And the OH concentration is given. That's 2.5 times 10 raised to negative 7. So, let's just divide them. Oopsie. Ayan. So, it's 1 times 10 raised to negative 14. Oopsie. Divided by 2.5 times 10 raised to negative 7. So, this is the concentration of H plus 4 times 10 raised to negative 8. And then we can apply it in the negative log equation. So that's negative log of 4 times 10 raised to negative 8. You'll still end up with the same answer. So negative log of your answer is 7.397 or 7.40 if you round it off. Okay? So both method will give you the same answer. Of course, kasi pare-parehas lang sila na formula. Okay? Ayan. Mas madali first method. Ako ito talaga ginagamit ko eh. So ano na, negative log, then after nun, 14, minus 14 na lang. Minus mo na lang siya sa 14. Okay? But again, there are two options in doing this. I want you to know that. Okay? So yan. Okay, nasundan. Ang dami nating progress today na. Don't worry, malapit na tayo matapos sa session today. Okay. So anyway, let's proceed with this one. Okay. So let's talk about the strengths of acids and bases. Okay? Siguro we'll end here. Okay? So hanggang dito tayo sa acid-base equilibrium constant. Pusin natin until here. So kung kayo ay gutom na, so just go and eat na lang. Okay? Anyway, okay. So we already defined what is an acid, what is a base, how to get the pH, the pOH, bakit 14 yung pH scale na. So all those questions have been answered na earlier today. Now, let's talk about the strength of acid. Okay, so basically this is just a review of your solutions. In your chapter 2 solutions, you know that there are two types of electrolyte solution. We have the strong electrolyte solution and the weak electrolyte solution. Okay, so when we say strong electrolyte, there's a full dissociation of your ions. Okay? So may full dissociation ng ions natin. Okay, so this is typical for metal and non-metal. Okay? Okay, so yan. For weak electrolytes, kumbaga, you do not have a complete dissociation. So that means partial yung dissociation niya. Okay, so not all of them are fully dissociated. And that can be observed with the use of this equilibrium arrow. So whenever you see an equilibrium arrow, that means it is not completely dissociated. Okay? Sa lahat ng dinidiscuss natin sa equilibrium, they are not fully dissociated. For acids, ganun din. Okay? So some acids are full in dissociation, some are weak. Okay? And there's many factor that causes that na. So these are some of the strong acids, no. Actually 7 sila. Pero itong 4 lang yung typical na ginagamit natin. Okay? So we have the hydrochloric acid, which is your muriatic acid. Okay? Your nitric acid, which is used in organic chemistry. Okay, so yan yung ginagamit talaga in organic chemistry because it is an oxidizing acid. Pero when you try to purchase that, it's very difficult. So in case na mag-thesis kayo, medyo mahirapan kayo to get nitric acid. Okay? Ginagamit kasi siya not only in research but also in the manufacture of drugs and bombs. Kaya maingat kami dyan. Okay? Pero it's a very strong acid. We also have perchloric acid. Okay, so HClO4. I don't know, saan siya ginagamit. And then we have the sulfuric acid, which is another strong acid. No? Ito yung nangyari sa lab gown ko. No? Nakwento ko ata sa inyo. I actually found the lab gown here. Nasa drawer ko na siya. Butas siya dahil sa sulfuric acid. Take note that the strength of sulfuric acid, yung strong acid na version niya is only the first dissociation. What do we mean by first dissociation? When you say first dissociation, only one hydrogen can be obtained here. So magma-minus 1 hydrogen ka lang. So for sulfuric acid, its strength is strong. Strong yung kanyang electrolyte kapag siya ay first dissociation. Siguro you might be thinking, can this further dissociate? Yes. Okay. However, meron naman tayong tinatawag called the weak acids. Okay. And as you can see, they are all accompanied by an equilibrium arrow, meaning that the dissociation is not full. Some of the weak acids include hydrofluoric acid, probably due to hydrogen bonding, it cannot fully dissociate. We have a nitrous acid, never encountered that in my life. We have bisulfate, okay. So this is the second dissociation of sulfuric acid. Okay, remember, yung first dissociation, only one hydrogen will be removed. This bisulfate uh, can further react, no? So that it will produce another hydronium ion. Okay, so it is weak na. And water, of course, water is a weak acid and a weak base as well. Okay, so do you need to remember this? Hindi naman. Okay, wag nyo na lang kabisaduhin, but you have to be familiar na. And as long as may equilibrium arrow ka na nakikita, that is probably a weak acid. For bases, we also have that, no? For example, bases of group 1 and group 2 metals, they are always strong acid. For example, sodium hydroxide, potassium hydroxide, and barium hydroxide. All of them produces the byproduct. Naglalabas sila ng OH. However, weak bases, as you can see, these are Bronsted-Lowry bases. So they don't really produce the OH, no, from themselves. Instead, nakukuha nila yung protons. No? They are proton acceptor as defined by Bronsted-Lowry base. No? So typically, weak bases are Bronsted-Lowry bases. Yung Arrhenius acid, yung Arrhenius bases, sila yung strong bases madalas. And you don't need to remember everything. All you have to do is to just look whether you have an equilibrium arrow or not. Okay. Also, in your chemical reaction, your conjugate bases don't have measurable strength. Rather, the strength of the solution, okay, or the acidity of the solution can either be inferred from only H3O and OH concentration. Okay, because the conjugate base doesn't have measurable strength compared to them. And this is the table showing the relative strength of acids. Remember, for strong acid, they are strong electrolytes, meaning there is a full dissociation, while for weak acid, there is no dissociation masyado. Okay? So if ever you have dissociation, that's very tiny lang, okay? So maliit lang ang dissociation. Okay? So to visualize that further, okay? So for strong acids, all of your substances are being converted into products, okay? Because of the full dissociation. Okay? So full yung dissociation. However, in weak acids, you have partial dissociation. Okay? So when we say partial dissociation, onti lang yung napupunta sa product side. Okay? Marami pa ring reactants, tas onti lang yun nasa product side. Okay? Ito ngayon yung question. The biggest question is, kunwari, you are given specific molarity of an acid. Let's say 0.5 molar HCl. Okay? Or 0.4 molar HF. Kunwari ganyan. You have 0.5 molar of each acid. Ang tanong, what is the pH of the solution? Can you easily compute for that? Okay. So ganito. Remember that when we are getting the pH, we have to get the negative logarithm of the H plus concentration. Okay. We have to get the negative logarithm of the H plus concentration. For strong acids, no, since the dissociation is full, madali lang kunin yung pH. All you need to do is to calculate, no, for the concentration of H plus using stoichiometry. So madali lang kapag strong acid. You can just use stoichiometry so you can get the pH of the solution. However, for weak acid and weak bases, you cannot directly calculate for the pH of the solution. Why? Because there is just partial dissociation. So anong gagawin mo? Okay. So in computing for the dissociation of H plus sa weak acids, you have to do what's called an ICE calculation. Okay, so gagamit ka ng equilibrium calculation or gagamit ka ng ICE table. Sa lecture class ko kanina, ito na yung sinasabi ko. Okay, so for weak acid, in order for you to get the pH of the solution, you have to do first what's called the ICE table calculations. Okay, so yan. However, if you have a strong acid, the dissociation is complete. So basically, you can just do stoichiometry. Okay, let me demonstrate to you how we can do stoichiometry for strong acids. Na? Okay. So let's try these two problems here. Okay. So sabi dito, what is the pH of a 2 times 10 raised to negative 3 molar nitric acid solution? Okay. Nitric acid is a strong acid if you still remember, na nakwento ko yung kanina. So nitric acid is a strong acid, no? So meaning it can fully dissociate into its ions, okay? Okay, so well, bali, if we write it, ganito siya. So HNO3, full dissociation into H plus and NO3 minus. So when getting the pH of the solution, it is not always the reported molarity, no? Hindi porket sinabi 2 times 10 raised to negative 3, yun na agad yung ilalagay niya sa negative log. No. What you have to do is to convert the concentration of your acid into the concentration of your H plus. Okay? Kailangan yung gawin. Okay? So let's do that. No? So sabi dito, you have 2.3, 2 times 10 raised to negative 3 molar of nitric acid. So for you to solve for the pH, you need to find the concentration of H plus. And that can be calculated using stoichiometry. No? Madali lang. Okay, so you have your molarity of H plus. Okay, you can get it by converting the molarity of nitric acid into the molarity of H plus. Now, how will you do that? Easy lang. Okay, kailangan nyo lang gawin is to just multiply the concentration by the stoichiometric relationship. Okay, so ganito lang gagawin nyo. So you multiply the molarity of nitric acid by the stoichiometric relationship as shown in your equation. So in the balance equation of dissociation of nitric acid, for every mole of nitric acid, you produce 1 mole of H plus, no? As shown in the balanced equation. So ibig sabihin, we can easily get the molarity of H plus. So that's 2 times 10 raised to negative 3 molar. Then I'll multiply it by the ratio 1 over 1. Okay? So maswerte tayo kasi direct na yung calculation ng molarity, no? Yan. So the molarity of the acid solution is 2 times 10 raised to negative 3 molar. Baka isipin nyo, sir, parang complicate nyo naman. Hindi, no? Kasi what if may coefficient dito na 2? Diba? So if may coefficient dyan na 2, edi you need to multiply everything by 2, right? Yun. So that's why we have to always follow stoichiometry talaga, na. Kasi sometimes it seems na parang parang overcomplicated naman yung steps na. Pero ganun talaga, na. We have to adhere to the rules of stoichiometry. Kasi what if may coefficient dito na 3, dito may 2? So, if you don't multiply them by their coefficients, then mali na yung sagot mo, no? So, lucky for us, the ratio is just 1 to 1. So, whatever the concentration of the acid is, yun na rin yung concentration ng H plus. So, to get its pH, you just get the negative log of 2 times 10 raised to negative 3. So, the pH is, ay nawawala yung calcio. Okay, so that's the pH. So it's 2.7. Okay, so 2.7. Siguro nagtataka kayo, no? Sir, ilan po ba dapat kapag pH? Multiple choice naman yung problems. So, you don't have to worry na kung ano i-report nyo. Pero ideally, 2 decimal places na. So, that's why ito ni-round off ko na. So, yan, 2.70. Okay? So, ganun lang. So, let's try the second problem. What is the pH of a 1.8 times 10 raised to negative 2 barium hydroxide solution? So, as I mentioned earlier, you have to show the dissociation of your compound first. So, let us show the dissociation of the compound. So, that will be barium hydroxide. It will dissociate into barium 2 plus and 2 moles of hydroxide anion. Okay? So, given yung molarity ng barium hydroxide, to get the pH, you can solve first for the POH. Kasi walang pH dito. So, kunin mo muna yung POH by getting the correct concentration of the OH. However, kung mapapansin mo, may stoichiometric coefficient. Saan kaya yun galing? Sa subscript, na? Just to make sure that the atoms are balanced, we write the 2 as the coefficient na. So, ibig sabihin, important talaga sa stoichiometry, no? Okay? Kasi if you don't consider stoichiometry, ni-negative log mo na lang to. You will get the wrong answer. Okay? So, that is why I want you to be very careful. Okay? So, given the molarity of barium hydroxide, so that's 1.8 times 10 raised to negative 2. Let's solve first for the molarity of the OH. Okay? We can convert the molarity by just multiplying them by the stoichiometric relationship. So you have the molarity of barium hydroxide multiplied by the stoichiometric relationship. So in the numerator, andun yung OH. And in the denominator, you have your barium hydroxide. Okay? So use the coefficients to balance them. So 2 to, ito 1. So yun ha. So you have to be very careful. Kasi baka mamaya negative log lang kayo agad na. So you might be forgetting the stoichiometric relationships. Okay? So there you have it. Na? So that's the molarity of the hydroxide. Sorry. It should be 3.6 na. So that's the molarity of hydroxide. So that's 1.8 times 10 raised to negative 2 times 2. So it will be 3.6 times 10 raised to negative 2. Okay? And then, what's next? You have the molarity of your hydroxide. You get the POH. Okay? So kunin mo yung POH. So POH is negative log of the concentration of OH. So that will be negative log of 3.6 times 10 raised to negative 2. Okay. 3.6 times 10 raised to negative 2. So that's 144. However, what we want is the pH. So you know that pH is just 14 minus the POH, right? Ginawa natin to kanina. So that will be 14 minus 1.44. 14 minus 1.44. Asan yung mouse? Ayan. The answer is 12.56. Okay. So, ganun ha. So, if you forgot to multiply it by its coefficient, mamamali yung answer nyo talaga. No? So that's why I want you to always do stoichiometry even though you are not really asked na, about it. So that you can know whether you're doing the conversions correctly. Okay? So usually ibibigay naman yung equations. Okay? Pero for strong acid, strong base, madali lang yan. Na? I just write the full dissociations. So what's our take here? Ano yung makukuha natin dito? That the pH of the solution can be easily obtained if you have strong acid or strong base, na? So strong acid, strong base, madali lang kunin yung pH because of the full dissociation. You can just use stoichiometry, na? Kasi full yung dissociation, right? Stoic lang siya. However, the problem arises when you have an equilibrium system, such as those in weak acids and weak bases. Kapag may weak acid ka and weak base, you cannot just use stoichiometry because there is a partial dissociation. So gagawin mo, you have to use an ice table or an equilibrium calculation pa. Okay? So ganun ha. So pag strong acid, strong base, stoic lang. Pag weak acid, weak base, you have to do equilibrium calculation. You cannot directly get the pH. No other choice. Not tayong choice. Okay, so now let's focus on acids and bases. Don't worry, tatapusin ko rin agad yung class natin after answering one item. Because I'm kind of dizzy na. Hyperacidity. Na hyperacid na ako. Anyway, let's talk about weak acids and weak bases. No? So since they are characterized by equilibrium arrow, ibig sabihin, we can write their equilibrium constant. No? So let's have, for example, the dissociation of weak acid HA. So ito, ano lang to, parang dummy equation lang siya. So let's say you have a weak acid HA. If it dissociates, you should show that it is partially dissociated na. So kumbaga may equilibrium arrow. So writing its equilibrium constant will give you H plus and the conjugate base on the numerator and the acid in the denominator. Okay? So the hydronium ion and the conjugate base in the numerator and the acid in the denominator. And yung Ka na yan, may value yan. Okay? So for example, ito, these are the common Ka of different acids. Okay? And you also have one in your canvas. Okay. Na-close ko ata yung canvas. Anyway. So, meron din sa canvas na pKa table. Okay? So, all of them are known na. So, hindi ka na manghuhula kung ano yung Ka. Kasi given na. Okay? Just here in this table. For weak bases naman, let's say we have ammonia. Okay? So this is an example of a weak base. It can dissociate to form your conjugate acid and the OH, no? So conjugate acid and the OH. So ito naman Kb tawag diyan, okay? B meaning base, okay? Yung A acid tawag doon, okay? So Ka meaning the equilibrium constant of the acid. Kb kapag base naman, okay? So yan. So as usual, numerator yung conjugate acid and your OH, and sa denominator yung iyong original substance. And every Kb also have their own value. Okay? So yan yung mga value nila. Okay? Tignan nyo, yung caffeine, base pala siya, no? Kaya mapait. Yan. Anyway, so yan. So again, yung ating weak acids, they are characterized by partial dissociation. So since they are partially dissociated, we can write their equilibrium equations. And when you have an equilibrium equation, you can write the equilibrium constant. For acid, the equilibrium constant is Ka, and for bases, the equilibrium constant is Kb. Insomnia? I don't know. Ano pa gamot sa insomnia? Ay, mali pala spelling ko. Ito daw, sleep medication lang. Kung kayo feeling nyo may insomnia kayo, pwede kayo manghingi ng what do you call this? Prescription sa health services. Pwede yan. Tulog. Pag di makatulog, ako ginagawa ko nung college, no? Face-to-face kasi nun eh. Nagdo-dorm ako. Nag-exercise ako. I mean, jogging lang. Maglalakad ka lang, tapos yan. Pagka-uwi ko ng dorm, tulog agad. Kasi ngayon, since mag-ano na lang kayo, makinig na lang kayo ng music. Dati kasi, when I was in Manila, nagdo-dorm pa ako sa Manila, doon ako sa Poreza. Siyempre, PUP ako galing, diba? So, Poreza Station, and then, every night, I jog papunta sa Malacanang. You will pass through Nagtahan Bridge. Then, may daan doon papuntang Malacanang. And then, from Malacanang, pwede ka dumaan pa San Beda. And once you're in Menjola, andun na yung UE, FEU. So, iniikot ko yan dati. Ganun. Malapit na siguro mag face-to-face because alert level 1 na. Hopefully by August, face-to-face na. Because, to be honest with you, ako rin, parang nauumay na ako sa online classes. No? Parang pretend lang tayo always. Okay. Sana mag face-to-face na para naman mas masulit yung tuition natin. Okay. And makapag-jogging din kayo. Pero kung magja-jogging kayo, masasabayan nyo ako if mag-dorm ako. Pero that's not likely to happen. Okay. So yun. Anyway, so ayan. So again, our acids and bases, since they are partially dissociated, they tend to show equilibrium expressions. No? May equilibrium expressions sila. And they have their own constant, the Ka and the Kb. Ka for acid, Kb for bases, and may values na yan. So, hindi ka na manghuhula. Kasi yan ay nasa table na, which I posted in Canvas. No? Nasa module 4. Amoy ng whiteboard. Ako, namimiss ko yung amoy ng laboratory. Alam mo yung amoy alcohol na ewan. Para ka nasa ospital. Ganun. Nakakamiss. Pati yung aircon. Okay. Okay. So anyway, let's answer just one problem. Okay, so for acid-base equilibrium calculation. Okay. So as I said, no, if you are going to solve for the pH of the solution, you cannot just simply use stoichiometry because of the partial dissociation. So you have to use an ice table. Okay, so just to recall, in an ice table, that is a table wherein we track the changes in the concentration of our substance. Na? I stands for the initial, C for the change, and then the E for the equilibrium. Yung initial, whatever is said in the problem, ipa-plug in mo siya. The change, so that depends on your reaction quotient. Pero just for simplicity, kapag zero yung products, edi to the products yung direction of the reaction, meaning the change in the product is positive. But if your reactant has no concentrations at all, then baliktad naman. To the reactant yung direction ng reaction, meaning the reactants will have a positive change. No? By how much yung change, we don't know, so we write a variable x. And then for the E, the equilibrium, we just combine the initial and the change so that we can get the equilibrium expression. We then plug it into our K value to get the X value. Yeah. So basically, magko-quadratic equation tayo. Yung approximation method, I'll teach that na lang in asynchronous video, ha? Kasi I'm very lightheaded right now. I think it's the acids. Okay. Ayan, so kakalculate natin yung X, and then from whatever equilibrium concentrations that we will get, we can then calculate for the pH of the solution. Okay, let's try this problem. So let's use ice table, okay, para makuha natin yung pH ng solution. So it says here, calculate the equilibrium hydronium ion concentration from 1.2 molar nitrous acid, HNO2, wherein the reaction HNO2 plus H2O produces H3O plus and NO2 minus. The Ka is given to be 7.10 times 10 raised to negative 4. So you have to make an ice table. Ayan na yun, naka-create na yung ice table. And then on the top, we write the reaction. In writing the reaction, you don't have to write everything. Just write the aqueous species. Okay? So yung water, hindi na natin siya papansinin. Okay? So I'll just write HNO2 in equilibrium with H3O plus and NO2 minus. Okay? So again, yung water, di mo na siya isusulat. Not necessary na. Okay? And then what else? Initial concentration. So according to the problem, we have 1.2 molar nitrous acid. No? So you just write 1.2 molar. How about H3O and NO2 minus? May sinabi ba? Wala, di ba? Ito lang sinabi eh. So kapag wala sinabi, meaning that the concentrations are 0. So the concentration of H3O plus is 0 initially, and the concentration of HNO2 is 0 as well. For the change, okay, so we'll just tell where the reaction is going. And as I mentioned earlier, kung nasan yung 0, dun papunta yung reaction. Okay? So what does that mean? So if the reaction is going to the product side, because the product side has 0 concentrations, that means the change there is positive. Dadami sila. Okay? While yung HNO2, ito naman yung mababawasan. Because ang mangyayari, yung 1.2 molar neto, ma-convert into products. Okay? Ma-convert siya into products. By how much, I don't know. Okay? So, yung change ko, since I don't know how much will be decreased dito sa left side, how much will be added to the product side, di ko alam. So, I'll just write X na. Yan. And always keep in mind, if you have coefficients, you have to include that. So let's say, kunwari, may 3 dito. So you have to include it, no? Kunwari, may 2 dyan, you have to include it. But thankfully, walang ganun. Buti na lang. Okay? So that's how you construct an ice table, right? The reaction first. Exclude the liquids, of course. And then for the initial concentration, if the concentration is not stated, then that's 0. Okay? And for the change, kung nasan yung 0, dun pupunta yung reaction. Okay? So let's say if you have 0 products, the reaction is going to the product. So you can translate it as positive X in your change row. Negative naman for reactants. Okay? And vice versa. And lastly, for the equilibrium, we just combine the initial and the change, no? So, ipag-add mo lang sila. So, 1.2 minus X. So, this is 0 plus X. which is x, and 0 plus x, which is another x. Now we have an equilibrium expression. So ano nang gagawin natin? These equilibrium expressions need to be plugged in to our Ka. Okay? Ganun ginagawa natin sa lecture, right? So after writing the equilibrium expression, yung may mga x, we plug them into our Ka. Okay? We plug it into our K. Let me just write the K expression. So Ka, this is the concentration of H3O plus, NO2 minus, and HNO2. And then, whatever is written here, plug in mo doon. So for the products, both of them are X. So X to, another X. In the denominator for HNO2, that will be 1.2 minus X. And then for your Ka, that's 7.1 times 10 raised to negative 4. Tapos ano na gagawin natin? We need to do the algebra. Okay, so algebra na. So let's cross multiply this into that. No? Okay. So sulat ko 7.1 times 1.2 minus x. Then this will be x squared, right? What's next? You distribute the term. So ito, I'll distribute it here. And ito, distribute it there. Yun. So distribute. When doing this, you have to be very careful. Especially, kunwari, FOIL method yan. Just like in the lecture. Kailangan maingat masyado. Also, do not round off any number that you will get. Okay? All decimals are important during the calculation. 7.1 times 10 raised to negative 4 times 1.2. That will be 8.52 times 10 raised to negative 4. Okay, so yan, 7.1 times 1.2 equals 8.52 times 10 raised to negative 4. And then, 7.1 times 10 raised to negative 4 times negative x. Okay, so that will be just negative 7.1 times 10 raised to negative 4 x. Okay, so ito yung ating equation. So 8.52 times 10 raised to negative 4 minus 7.1 times 10 raised to negative 4x equals x squared. Okay? Tapos ano pa gagawin natin? So gagawin natin, we arrange the equation into the proper form of polynomial. What is that? Ax squared plus bx plus c equals 0. So magsama-samahin natin sila sa isang side. Okay? So I'll delete this ha. Okay, kasi wala na akong space. So, pagsama-samahin natin sila sa iisang side. So, yung x squared, lipat ko sa kaliwa. So, as I move my x squared here, it will become negative sign. Magiging negative siya. So, negative x squared minus 7.1 times 10 raised to negative 4 plus 8.52 times 10 raised to negative 4 equal 0. Okay. So, yung x squared nilipat ko lang sa left side, kaya siya naging negative. However, sorry, I forgot the x here. Okay, so negative x squared minus 7.1 times 10 raised to negative 4x plus 8.52 times 10 raised to negative 4. Okay. So, ano yung however natin? When writing the proper polynomial, the first term must be positive. Okay? Yung x square natin, it should be positive. So what we will do, we need to multiply the entire equation by negative 1. So multiply ko yung buong equation by negative 1. So negative times negative, magiging positive. Negative times negative, magiging positive. Negative times positive, magiging negative. Okay? So basically, just flip the signs. Na? Bakit ganon? Ganon kasi talaga, sabi ni algebra. We don't have choice but to follow. Okay? So that's the proper way of writing polynomials. The first term will always be positive. That's why I multiplied everything by negative 1. So now, as you can see, our polynomial have coefficients, no? The a, the b, and the c. And we will use them to solve for the root of the polynomial. Okay? So the coefficient of x is 1. X squared. That is 1. So yan yung a natin. The coefficient of x only is this one. 7.1 times 10 raised to negative 4. And the coefficient c is this one. Negative 8.52 times 10 raised to negative 4. Pag may negative sign, kasama siya, ha? Okay. So now, ano nang gagawin natin? We can do quadratic equation. Okay, so x is equals to negative b plus minus square root of b squared minus 4ac over 2a. Pero, sabi ko nga sa lecture ko, tamad tayo. So, pag sinabing tamad, ibig sabihin may shortcut. Okay? So, just like in your lecture, we will do the same technique. We will use the calculator so that it can solve for the roots of our polynomial. Okay? So, let's open our calculator. Asan yung mouse? Ayan. So, let's open our calculator and let's access the equation function. Sa mga hindi ko lecture student, so ganito gagawin nyo. You just press the mode and then press equation and then, ano ba napindot ko? 5 pala dapat. Okay, so you press equation, which is 5, and then you will be given several options, right? So since this is a polynomial of degree 2, so meaning naka-x square siya, so you choose number 3 kasi yun yung may x square. Okay, so you press number 3. And then you are given this picture. May A dyan, may B, may C. Gagawin nyo na lang, you plug in the coefficients 1, 7.1 times 10 raised to negative 4, and negative 8.52 times 10 raised to negative 4. For those using ClassWiz, okay, tingin na lang kayo sa monitor ko. Dito sa aking camera. Yan. So for those using ClassWiz, all you have to do is to press the menu. And upon pressing menu, you will be given several options here. So scroll down lang kayo. And then may makikita kayong xy equals 0. So you have to select xy equals 0 by pressing the equal sign. Okay? So xy equals 0, equal sign. Then may ganitong question. So simultaneous equation, this is what we use in gravimetry. Kung naalala nyo yung xy, dito yon. But this time we have a polynomial. So you just press number 2 for the polynomial. Napindot ka ba? Ayan. So after pressing 2, I was asked, what is the degree of my polynomial? So the highest exponent is the degree. So the exponent here is 2. The highest exponent is 2. So ibig sabihin, the polynomial degree is 2. So just press 2. And then you will be given the same screen as what we have here in our um, calculator sa laptop. Okay? So you will be given the same screen as what we have in the laptop. Now, ano na gagawin natin? We can plug in now the coefficients A, B, and C. Sensya na, medyo binibilisan ko na ha. Kasi I'm kind of dizzy na rin. I am yet to take my brunch. Okay. So let's answer A, B, and C. Okay, so for A, that's the coefficient of x squared, which is just 1. Plug in natin 1. And then press enter. For B, that is 7.1 times 10 raised to negative 4. 7.1. Oopsie, what happened? Wala ako nakalamlak. 7.1 times 10 raised to negative 4. And then for C, we have negative 8.52 times 10 raised to negative 4. You include the negative sign, ha? So that's negative 8.52 times 10 raised to negative 4. Just verify your answers here. So A is 1, B is 7.1 times 10 raised to negative 4, and C, including the negative sign, that's negative 8.52 times 10 raised to negative 4. Then what you will do next is to press enter twice. Okay, so pressing enter twice gives you the roots of your polynomial. The number of degree of a polynomial tells you how many roots you have. So since ang exponent natin is 2, the degree is 2, ibig sabihin dalawa yung roots natin. So let's press equal sign. You have the first root, which is 0.029 molar. Okay, sulat ko na dito. Burahin ko na to ha. Kulang ako ng space. So the first root is 0.029 molar. Okay. So molarity yan. That's the concentration X. So 0.029 molar. And the second root is negative 0.295 or negative 0.30. So yun yung dalawang root natin. Itong minima, maxima, sa calculus yan. Okay? The minima, maxima of the graph. Anyway, so ito lang kukunin natin sa x1 and x2. And since we have two roots, ano gagawin natin? We have to check which of them is applicable to our problem. Okay? So, sabi ni Louie, x na si x2. Bakit? Kasi, always remember that there are no negative concentration. Walang negative na concentration. Ayun, may utang pa. Walang ganun. So, if you plug in x2 as your x, negative yung concentration ni H3O. Walang ganun. Okay? So, walang negative. So, piliin mo yung positive, no? So, if you are asked between a negative and a positive root, always choose the positive root. Okay? Paano naman po kapag parehas na positive? If they are both positive, just like in your lecture, ang gagawin mo, you choose the concentration or you choose the x value that is less than the original concentration. Okay? Kung naaalala nyo pa kanina. Okay? Kunwari, yung isang root dito, 1.5. Kunwari lang. Tapos yung isa, let's say 0.03. So, sino pipiliin mo? Siyempre, yung less than 1.2. Because if I chose a root that is bigger than my original concentration, then magiging negative na naman yung concentration. Basta always remember, there are no negative concentrations. Puro positive lang siya. So, of the two roots, I'll choose the first root, which is 0.029. Okay? So, ipa-plug in ko na yan dito sa x na. So, to complete the problem, that's 1.2 minus 0.029. This is 0.029 and 0.029. So, meaning the equilibrium concentrations are, okay, for the nitrous acid, so that's 1.2, sorry. Let's clear the calcu. So that will be 1.2 minus 0.029, 1.1171. Yan yung equilibrium concentration niya. And for the H3O plus, you have 0.029. And for the nitrite ion, also the same, 0.029 molar. Okay. So yun yung mga equilibrium concentration nila. However, ang tanong sa atin, na kunwari, hanapin natin yung pH. Okay? So to solve for the pH, we will need to use the equilibrium H3O concentration. So ito yung gagamitin natin. Hindi ito ha, not that. Instead, yung equilibrium concentration. So we'll do that. So that's negative log of the H3O plus. Baka nagtataka kayo, no? Kasi yesterday, tanong sa akin, Sir, yung H3O po ba, pati H plus, parehas lang? Yes, parehas lang sila. Okay? So that's why I interchange H3O and H plus. Okay? Nagpapalit-palit ko siya. Okay, so in getting the pH of the solution, always get the concentration of H3O plus. So that will be negative logarithm of 0.029, or the pH of the solution is 1.54. Matapang yung acid, yes. Ayan, so ganun siya ka-acidic. Okay? So ganun lang, no? So imagine, ang dami niyong gagawin, no? Just to get the pH. Ganun talaga. Okay. Pero don't worry, masasanay din kayo eventually. Kasi pagdating natin sa chapter 5, which is after the midterms, sa titration, dun mas matindi yung equilibrium calculation dun. Like, kailangan mabilis ka talaga mag-solve ng equilibrium. Okay? Pero may shortcut dyan, no? So, yan. May shortcut, which is ituturo ko na lang in an asynchronous video. Kasi I'm kind of dizzy na. Okay. Yan. Yung shortcut, madali lang siya. So, basically, ang gagawin mo, instead of doing equilibrium, mag-shortcut ka na lang. Okay? So, ganun. Siguro ituro ko na lang din na para ma-practice nyo na lang at home. Okay? So, sige, ituro ko na. Okay. Kaya pa naman eh. Okay. Pero ganyang kahaba yung process na just to get the pH. Tapos 1 point lang yan sa quiz. Ganun talaga. So, laban lang na. Let me show you the shortcut, no? Okay. Kasi yung shortcut, yun at yun yung gagamitin natin sa next chapter. Ang gusto ko makita nyo na may other way, no? Kasi if we continue doing equilibrium, nakatamad mag-aral. Nakalungkot. So, gawin natin yung shortcut, okay? So, let me share you the shortcut, which is the small x approximation. Kung kayo napanood nyo yung aking mga older YouTube videos, ito yon, small x approximation. Diniscuss ko yun dun. So this shortcut will actually help us to eliminate the use of quadratic equation. Okay? Para hindi na tayo mag-quadratic, pwede natin gamitin yung small x approximation. But when it is applicable, it is only applicable if the concentration of your reactant divided by the equilibrium constant is greater than 1,000. Doon lang siya pwede gamitin. Pag hindi siya greater than 1,000, then mag-ice table ka. You'd have no choice but to use ice table. Okay? So tandaan nyo yan. This shortcut or the small x approximation can only be applied if the concentration of your reactant divided by the K is greater than 1,000. If so, ganito gagawin. Okay. Tuturo ko mamaya onte. Paano kapag hindi siya greater than 1,000 po? E di mag-quadratic ka. You have no choice but to use quadratic. Okay? So let's check if this problem is applicable. Applicable ba yung small x approximation? Ano sabi ko? First, you have to check if the concentration divided by K is greater than 1,000. Okay? So yun yung una mong gagawin. Kunwari, nagko-quiz ka sa Canvas. So yun yung first mong gagawin. Check if the concentration divided by the K is greater than 1,000. So this is the initial concentration, right? So it's 1.20. Divided by the equilibrium constant. So 7.10 times 10 raised to negative 4. Saan siya equal? Let me try na. So 1.20 divided by 7.1 times 10 raised to negative 4. Okay? Pwede naman calculate yung quadratic, yes. Pero kunwari, applicable naman yung small x approximation, wag ka na mag-quadratic. Okay? Nakikita nyo, super bilis ng calculation. Ako, pag nagsasolve ako neto, tapos pwede gamitin yung small x. Wala pang 30 seconds, may sagot na ako sa isang problem. So, I want you to develop that kind of skill. No? Kaya tinuturo ko yung shortcut. Okay? So, again, ito yung problem. So, first you check the concentration divided by K. Is it greater than 1,000? Tignan natin. Yes, it is greater than 1,000. So, it's 1,690. So, indeed, greater than 1,000. So, ano pwede natin sabihin? Pwede si small x. Okay? So, pwede si small x approximation. Okay? So, pwede. And now, ano na gagawin natin? This is what we're going to do. Let's look at the previous slide. No? Ito. Ay, nabura ko pala yung equilibrium constant. Anyway, I'll rewrite the equilibrium constant. No? I-rewrite ko lang para makita nyo kung saan i-apply yung small x. No? Pero if applicable yung small x, you really don't need to do this anymore. I just want to show you saan siya na-apply. Okay. Remember, kanina in our ice table, this is 1.2 minus x, this is x, right? Di ba naalala nyo yan? Ayun, kanina. Tapos itong equilibrium, ipa-plug in mo sa Ka, di ba? So you have 7.1 times 10 raised to negative 4 equals x times x here, then divided by 1.2 minus x. Ano ba yung dahilan ba't nag-quadratic equation tayo? The only reason why we did quadratic equation is because of this x term here. Ito yung may kasalanan ba't tayo nag-quadratic. Diba? Kasi naging ganito yung equation eh. No? Kapag may small x dyan, ang equation natin magiging ganito. X squared plus x plus something equals 0. So, kailangan mo talaga mag-quadratic. Imagine if wala yung x na yon. If wala yung x na yon, our equation can be just written as ax squared plus c equals 0. Mas madali mag-solve ng mas madali mag-solve ng roots kasi you just need to get the square root of c, right? So, kukunin mo na lang yung square root na. Kunin mo yung square root nila, di ba? So, yun yung purpose ng small x approximation. Okay? To get rid of that x sa baba. Okay? So, yun yung pinaka-goal niya. Okay? So, it will help us get rid of this x. No? Buburahin natin siya. Since sabi natin, greater than 1,000 to, pag greater than 1,000 yan, you can just simply erase this. Okay? Pwede mo na burahin yon. Allowed ka burahin yon. Okay? And then what will happen? Things will be much simpler now. So this is 1.2 times 7.1 times 10 raised to negative 4 equals x squared. Without that x term, we can just simply get the value of x by getting the square root of the product of the concentration and the Ka. Okay? So, dahil doon sa pagbura natin sa minus x na yun, mas lalong napadali. So, what's the value of x? No? Nakunin natin. So, what will be the value of x? So, that will be the square root of 1.2 times 7.1 times 10 raised to negative 4. 0.029. Di ba yun din yung na-solve natin kanina? 0.029. Yun yung value ng x, di ba? So, yun yung kagandahan ng small x approximation. So, if you don't want to do quadratic equation, you have to check first if the ratio of the concentration and the K is greater than 1,000. If it is greater than 1,000, then you can just simply erase the minus x here. By eliminating the minus x, you don't need to do quadratic equation anymore. All you have to do is to multiply the concentration of acid times the Ka and get its square root. So, bale, it is now just square root of tsaka. Okay? Yung pagkuha ng x ay square root na lang ng tsaka. Okay, tandaan nyo yung tsaka. No. Ayan. Ito kasi ginagamit kong mnemonic. Pag nakalimutan ko, square root of tsaka. Okay, what does that mean? To get the x using the small x approximation, all you need to do is to just get the square root of the concentration of the acid times the Ka. CHA, concentration of acid. Ka, ano yung Ka? Square root of tsaka na lang. Na? So, yan. So, kunin mo na lang square root nito. At ito, pag minultiply mo sila. Okay? And ginawa ko na nga yung kanina. So, this is the square root of tsaka, which gave me 0.29 as my x. Na? So, 0.029 yung x ko. Which is the same as what I solved earlier. 0.029. Nung tinuro sa amin to, natatawa din kami. Square root of tsaka. Pero eventually na namin, ay oo nga no, mas mabilis pala siya. Diba, tignan nyo, quadratic ka pa ba? Hindi na. Gagawin mo na lang, divide mo muna si concentration by Ka. If greater than 1,000 yon, edi mag-square root of tsaka ka na to get the x. That's simple lang. Kaya whenever I am taking exams, no, even sa grad school, nagagamit namin to. Um, when I am taking exams, wala pang 30 seconds, tapos na ako. See, mabilis ang pindutan lang. Concentration divided by Ka. Pag greater than 1,000, edi square root of tsaka, I got my answer na. That's it. Okay? So, ganun. So, I want you to try that one. And this square root of tsaka, no, magagamit natin to until the end of the semester. So that's why I want you to share. I want to share you this, this tsaka. Okay. So yun, tsaka as in pangit na. So yan, galing na. Yan. So anyway, pasensya na. I think you are kind of overwhelmed with the information. Yeah. Even though na 2 weeks yung ating chapter 4, I decided to cover at least half of the lesson today, and then asynchronous na lang yung next meeting para mas marami kayong time on your own na. Mas marami kayong time to practice na. So ganun, practice lang. Okay? So yun. So natapos na natin yung small x approximation. So hopefully aralin nyo rin siya. And you can apply it in the worksheet problems in our Canvas. So log in lang ako. Mawawala sa exit denominator. Yes. Shortcut kasi siya. At saka tignan nyo yung nakuha nating x sa square root of tsaka and the quadratic equation. Same lang. Diba? Galing na. Anyway, you can use the lessons in the lecture. Sorry. Mag-upload pala ako sa lab. I forgot. May mga worksheet for the laboratory which I am yet to upload. So, abangan nyo na lang. So, maybe after ko kumain today. So, ipopost ko na lang yung worksheets. No? So, for example, this one. Hindi, masyado mahirap pala to. Wala pa tayo dito. Separate video pa yan. Wala pa pala. Sige, magdadagdag na lang ako ng problems. Hindi pa pala kompleto to. Okay. Pero alam ko meron na rin sa lecture. Tignan ko lang ha. Hindi ko na maalala. Okay, so tignan natin. Ayun, so ayun, kita niyo yun. Calculate the equilibrium ion concentration. Okay. Ayun na pala yung sinagutan natin. Anyway, so ayun. I'll give you more problems na lang wherein you can utilize the square root of tsaka. Okay. So that you can easily solve for the x na. No need for quadratic equation. So ano lang gagawin mo? Divide the concentration by Ka. If that's greater than 1,000, then you can just simply erase this minus x. Pwede mo na siya burahin. And upon erasing that, your equation can then be simplified. No? You just need to get the square root na lang. The square root of the concentration times the Ka, and the x value is just the same as the quadratic version. Okay, so I think that's all muna for today. For next meeting, wala tayong synchronous session because everything will be done asynchronously na lang. So maybe I'll post the video by tomorrow. Okay, so I'll post the video by tomorrow so that you can watch it na and study it until next week na. Okay, So, ganun na lang. So, this will be our last synchronous session for the midterm. Kita-kita na lang sa March 29. Okay? Kasi ano na tayo, puro asynchronous na tayo. To give way for your finals na para mas marami kayong time on your own. Again, reality check lang. So, March 14 to 19, midterm week. March 21 to 26, yan ay consultation. I will give your grades by March 24. And then, March 29, magkaklase na ulit tayo. Okay? Pasensya na, no? Overwhelmed talaga. Medyo marami kasi akong kinover ngayon. Okay? Dinamihan ko talaga para susunod onti na lang. Okay? So yun, ito na lang naman yung i-cover natin. More on acid-base equilibrium calculations. Protic-triprotic buffer solution and the solubility equilibrium. Ting slides na lang. Okay, so antayin nyo na lang yung video. Popost ko na lang siya. So with that in mind, I'll see you again on March 29. So that's after the midterm consultation. But in the meanwhile, ingat muna, and pag may problem kayo when it comes to the discussion or let's say sa experiment, let me know. Okay? Just send me a message in MS Teams. Okay? Thank you. I'll see you again, and bye-bye. Ingat. And see you on March 29.